I'm here to assist you with all your test equipment needs, from multimeters and test weights to patient simulators and x-ray analyzers. If you need guidance or you have any questions, please don't hesitate to write me at jbarber@bcgroupinternational.com. What's up, everyone? Welcome back to Better Biomed. Holy cow, this was a bit of a project. Oh, it looks like chaos down there, right? And believe it or not, it is organized chaos. So this is my third video in the series of changing out a standard controller, which is right here. And that's my standard Nuvoton controller with LED readout. And I also changed out, well, I kept the power supply, but I also changed out the control board, which is this guy right here. This guy here receives instructions from this guy on what relays the clickety-clack, turn on, turn off. And this guy ended up popping. Take a look right there. That guy right there, it popped. And this guy right here, look at it, it's missing its face. It popped right in my face, man. Not cool. And I double checked. I took a photo of all the wiring, everything before I hooked this guy up, and it still did it. So one reason is because it is definitely old. The other reason is the weakest link always fails. And once I solve one problem, then the next problem is going to happen. So interestingly, I was able to convert this all over. And like I said, it looks like chaos, but believe it or not, this is all fixed down. And yes, I do have it sitting on MDF because MDF is an insulator. Not that I really need one, because we went from 12 volts and AC to 5 volts and AC. And I kind of walk you through what's going on here. So my AC comes in and it splits off, even though this one's red and black. This one here is also AC, which ran over to the control board, or the switchboard. This guy's the switchboard. You can see there's a lot of relays on there, and I had to change this functionality. So I've got a Arduino Nano right here, and that's this guy right there. You can see I left the port accessible so I can upload new software, and it is technically completely sealed in hot glue. So I have both rails on the sides. I got 5 volts and ground, or 0 volts on both sides. And this little bundle right here, I'm going to finish out tomorrow. So I have one ground wire, and I've got power, start, lid up, and lid down. And those guys are right here. So tomorrow I'm going to wire these guys into these wires right here. And then my buttons will be functional yet again. So that takes care of that. That's just the signaling. My Arduino is running on 5-volt circuit, which, yeah, you can see I've got these push-in connectors, and it's all running on low voltage. So, and I did tin the wires so that they push in, and it is a firm connection. So all you naysayers out there, they're like, oh no, you can't do that. Trust me, you can. And it is a very firm connection. So no worries there. I already multimeter checked it, and it's really low ohms, almost 0. So very good. I got my 12 volts that comes off this board. That's the only board that I'm keeping, because it's got the splitter for the 120 volts, and then it's got the 12 volts. So everything in here runs on 12 volts. We got this solenoid here and this solenoid right here. I'm running them in parallel. So even though like this one here doesn't give out as much air as this one when they're both activated, they have the exact same part number, which I'm really confused. And look, they're hooked in parallel. So all I guess is that they were hooked in parallel on the board as well. There are these ones over here. And if you look right there, they are indeed hooked in parallel. So that's what I did. And I've got those in my 12 volt circuit, which this one right here is my 12 volt circuit. These two right here coming off of my DC 12 volt to 5 volt converter. If that looks familiar, it's because that's an old Carl Storz part from their old video installs, and I kept it because it kicks out 3 amps at 5 volts, and that is pretty good. Pretty good. I'll take that any day. And so 12 volts in, and then it kicks out 5 volts. So my relays and everything are being switched at 5 volts, and these solenoids, even this little guy right down here, they're all 12 volts. This motor right here, that is the up and down, that is run on 12 volts. So that was one of the biggest challenges. You see this 4 relay pack back here, which that reminds me, I have not glued down any of these wires back here on the signals. It is stealing its 5 volts off of these rails. Should be no issue. These guys are really low amperage to clickety clack those. But these right here are the signal wires. And those signal wires come from, let's see, over here, down. So it comes in here, and when that guy activates, it clicks these guys on, and then those guys do some magic. This is basically what's going on, guys. So my relays here are basically run it in normal polarity, and then they switch the other two over, and they will reverse the polarity, making it a reversing motor because it has to do lid up and lid down. So I basically wired them like an H bridge over here. And then I had the other problem is that I can't have it running all the time. So I have to be able to turn it on and off. So you can see this was quite the, by the way, this is not connecting, it's jumping. But you can see what I did. My 2 relays over here, I got it connected like an H bridge. And I've got one 12 volt lead over here to the normally open. And the other one is coming down to my forward relay. So when the forward relay clicks on, this guy slaps over, and these guys here are not energized. So this guy here is going to be energized, and this guy right here is going to be on -12. So it's going to be energized. So that's my motor. So that's running in normal polarity. And when I click on the reverse, it's feeding 5 volts over. That's going to activate these 3 relays. So this guy here is going to click over 12 volts. Meanwhile, this guy here is going to click over here and here. So this guy here is going to be the positive, and then this guy here is going to be the negative when it clicks over, and that is going to reverse the polarity of my motor. And believe it or not, maybe because I was tired today, maybe because I kept getting interrupted, I ran through so many iterations of this circuit to figure out what the hell, how was I going to do it? And guys, it would have been so much easier if I had 12 volt relays. These are 5 volt relays, which meant that I have a whole new challenge. If it was 12 volt, it would have been easy. I would have just had this one turn, those ones on, etc. Not a problem. But they are 5 volt relays. So that means that I'm going to drive one of these, my up, I'm driving with 12 volts. And then my down, I'm driving 5 volts to clickety clack those other ones. So that's what's going on. If you guys understand that, it's really kind of crazy. So that's my 12 volt coming in. That's my 5 volt coming in. Yeah. And these guys over here are driven by the Arduino right there. So these guys here, they all work. They work beautifully. So now, how are they going to work with all that? Well, I've got my 12 volt and my 5 volt. I actually have the 2 negatives connected together because they have to be able to reference each other. So that was one of the other things that I was cognizant of. And I have the vacuum pump right there. This big old guy. That's one of the reasons why I want to keep it, because it's in excellent condition. My vacuum pump and my heater right here are both feeding off my 120 volts. And you can see how I got them split off down here. So this is my hot leg. This over here is going to be my common neutral. So these ones here come over, they get driven, and then they clickety clack over, and then it goes into respective feature. So one of them is going to be my heating bar, which is right there, right there. It's going to activate the heater. That's that guy. And that's going to seal the bag. And meanwhile, it's going to drive this guy right here, which is going to raise the sealing bar. And theoretically, it should all work. So anyway, that's it. Tomorrow I'm going to finish wiring up the AC, and I'm going to wire up these buttons, which honestly is only going to take me a minute or so. It's just a couple minutes really, and it's ready to go. But I'm going to save that for tomorrow. My back is actually killing me. And you can see I've got a lot of stuff going on. I'm a firm believer in using these fair rules, guys. Very firm. You can see I use them, even though my wiring code, I didn't stay completely consistent with my wiring code. I still know what wires are driven to what, and the ones that are kind of important I did label. So yeah, organized chaos. Anybody else that comes in here, they're going to be like, what the hell is this? And they're going to trip out, but it's going to work. We got my limit switches over here, fed in over here. Everything is set and ready to go. All I got to do is wire in my control panel tomorrow and give it a test. Let's see how it works. And then I got to do some wiring management, because you can see right here, we've got a spur gear, and the last thing we want to do is get any wiring caught up in here, especially 120 volts. That would be very dangerous. So all the 120 volts going to be kept back here in the corner, and all my low voltage is going to be up here, except for obviously the ones that are switched. And that will maintain its safety, hopefully. And I'll do some wiring management over here when I know that it's fully functioning. Because if it's not fully functioning right now, if there's any hiccups, at least here I can troubleshoot what's going to what. If as soon as I start like putting wire ties on it, cable ties, then your troubleshooting ability goes down dramatically. But there it is, 12 volts, 5 volts, 120 volts, Arduino controlled. And we're going to give it a run tomorrow. Thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.